Okay, so the sum of the first n terms of a geometric progression with the first term to be a1 and its common ratio to be r is given by Sn equals ar exponent 0 plus ar exponent 1 plus ar exponent 2 plus ar exponent 3 as it goes plus ar exponent n minus 1. So in this case, we are going to multiply through by our common ratio, which is r. Good. So multiplying through by the common ratio r, this is what we are going to get. How did you get the ar exponent n? We applied the law of indices. That is the quotient law. So let's prove it. Okay, so the quotient law of indices, that is a division law. When numbers of this are the same base and that they are divided, what do we do to the exponent? We subtract their exponent. So in this case, it became good. So then we multiplied it by r. So r cancelled out. So that's how come we have ar exponent n. So this will be our first equation and this will be our second equation. So let's study the two equations very well. Looking at the two equations, we will first of all subtract, so equation 1 minus equation 2. So we first of all subtract equation 2 from equation 1 to give us this is our equation 1 and this is our equation 2. So this will be all these ones will cancel out. So you'll be left with ar exponent 0 minus ar exponent n. Good. So this will be a formula. So let's take note of this. When you finish, we can see that we can factorize some things out here. We have some common letters here. For the first part of the equation, we can factorize Sn out. So factorizing Sn out will give us this place will be left with 1. And this place will be left with r. We are proving a formula. Good. Looking at this side too, any number exponent 0 is 1. So this place will be left with a. But looking at the two equations, we can factorize a out to give us. So factorizing a out, you will be left with 1 minus going to use when our ratio is greater than 1. So, in this case, we are going to, as we did for the first one, we subtracted equation 2 from 1. But this time around, we are going to subtract equation 1 from 2. So, it's going to be equation 2 minus equation 1. Where is our equation 2? That is our equation 2. And this is our equation 1. So we subtract the two equations. Good. So, as usual, they will cancel out. So you'll be left with r Sn minus Sn equals AR exponent n minus AR exponent 0. We now factorize our common letters out. Great. So factorizing this out, Sn will come out because Sn is here and Sn is here too. So when you take Sn from our Sn, you'll be left with r. And when you take Sn from Sn, you'll be left with 1. Coming to this side too, when you take a out, you'll be left with ar exponent n. When you take a out from here, you'll be left with r. Sorry, you'll be left with 1 because any number or any letter exponent 0 is 1. Great. We are not done. We are looking for Sn. So what do? We divide both sides of the equation by the coefficient of Sn or by anything attached to Sn. So this is attached to our Sn. We are going to divide both sides of the equation by that. Then we cancel out to make Sn stand on its own. Okay, so therefore we can say that Sn is equal to a bracket r exponent n minus 1 over r minus 1. You use this equation when your common ratio is greater than 1. When r is greater than 1. So always check when you are given the question, please check the absolute value of your common ratio. When r is less than 1, you know the formula to use. And when r is greater than 1 too, you know the formula to use. Please don't interchange them, else you'll be marked wrong. Now let's see this question. So it looks